In November of 2019, a mysterious object was spotted in the Crane constellation in the southern hemisphere, or rather the sky of the southern hemisphere, traveling at a velocity that should be impossible for a natural object. 1,755 kilometers per second, or nearly 4 million miles per hour, 0.6% of the speed of light. Just to give you an idea of how fast this is, were this object in our solar system, it could travel from Earth to the Moon in less than 4 minutes, or from Earth to Mars, at least at the moment of closest approach between the two planets, in 8.7 hours. A planet that's going to take 6 months for us to reach with our current technology, this object could cover that distance in 8.7 hours. It's difficult to believe, and indeed, the astronomers who first detected this object rightfully believe that their readings might have been incorrect. But after a lot of confirmation, it was determined definitively that S5HVS1 was traveling at this kind of velocity. And it's not the only one. There are a number of these mysterious objects blazing through our galaxy at a speed that is not only fast enough to escape any star's gravity, regardless of how huge, it is also fast enough to escape the galaxy altogether. We are therefore not talking about interstellar objects, we are talking about intergalactic objects. However, there is a natural explanation for these objects, an enormously powerful force within our galaxy that could theoretically drive these objects to this kind of velocity. But one thing that astronomers never investigate, and mainstream science does their best to studiously ignore these possibilities, are artificial means of making this happen as well. An artificial explanation for what we are observing. These impossibly fast objects who are currently on a journey that's going to take them out of our galaxy to destinations unknown. And we are going to examine both the natural and artificial explanations for these mysterious objects in this episode of The Angry Astronaut right now. Good morning, alien enthusiasts, and welcome to another Angry Alien Bulletin. Today, we are going to be talking about mysterious objects that are hurtling through our galaxy at what appeared to be impossible speeds when they were first discovered. No, we're not talking about UFOs in the conventional sense, or even large asteroids, comets, or anything similar to 3I Atlas. What we are instead talking about are stars, also known as hypervelocity stars. I've talked about them a couple of times on this channel, but it's been almost a year, and I picked up a lot of new subscribers since then, and also there have been a number of new discoveries made about these mysterious objects that I think bears paying some attention to. So first of all, how does science explain these things? How is it possible for stars to be traveling at this kind of velocity, not only fast enough to go from star to star relatively quickly, but also to escape the gravitational influence of the entire galaxy? What could possibly do this? Well, as I've discussed a number of times on this channel, there is a massive black hole at the center of our galaxy, a supermassive black hole. And if a binary star makes a close enough approach to a black hole of this size, the energy gets transitioned from one star to the other. This binary pairing, when exposed to an enormous amount of gravity, not enough gravity to yank the stars over the event horizon or anything like that, just more of a close approach with a black hole of this size, one of the pair gets ejected at enormous velocities. And the one object that we talked about at the beginning of the episode, it does appear that it did indeed come from this region of space, which, interestingly enough, is the same region of space that 3I Atlas came from. So yes, this natural explanation seems to hold up. And if the vast majority of these hypervelocity stars were indeed coming from the center of the galaxy, then that would make a great deal of sense. But the problem is they aren't. A minority of hypervelocity stars are coming from this region of the galaxy. There are stars traveling nearly as fast, blazing through the galaxy from every which way but loose, and there doesn't seem to be a solid natural explanation as to why this is the case. Even if a majority of these hypervelocity stars were coming from the galactic core, that would make a great deal of sense. But that isn't the case. Instead, what we have is an equal number of stars that seem to be coming from a region of space dominated by what is called the Large Magellanic Cloud, or the LMC, a much, much smaller galaxy than the Milky Way that is orbiting our own galaxy. So maybe the Large Magellanic Cloud has a supermassive black hole, although it would have to be a similarly huge supermassive black hole to have ejected all the stars it appears to have ejected. And guess what? In spite of many attempts to observe a black hole in this particular galaxy, this satellite galaxy of the Milky Way, we have seen no evidence whatsoever of a supermassive black hole or a black hole of any kind. And this, once again, is not the only example of a point of origin for these mysterious hypervelocity stars. They're coming from other regions of space as well that seem to have nothing to do with supermassive black holes at all. And so when confronted with these inconvenient facts, the conclusion that scientists come to is that, well, then it must have been something else, a supernova of some kind in a binary pair with another star being really, really close to the supernova, and that could possibly eject it at those kinds of speeds. But unfortunately, recent discoveries seem to disqualify that explanation as well, at least for some hypervelocity stars. So at this point, we need to also look at artificial explanations, even though mainstream science will definitely not do that. So first of all, let's learn a little bit more about these hypervelocity stars, where they are in our galaxy, including, by the way, a hypervelocity star that's extremely close to our sun, uncomfortably close actually, where they appear to be coming from, where they're going, and why natural explanations just don't work for all of them. An astonishing fact known only for the past few decades is that every big galaxy in the universe has a supermassive black hole at its heart. Scientists suspected that this was the case in the 1980s. Strangely enough, so did I. Yeah, even when I was a kid, it occurred to me that all of the material in a galaxy might coalesce at the center of a galaxy, creating a massive black hole. Can't believe I was right about that. Just pure luck, I guess, but still, believe it or not, I actually believed that myself in the 1980s. All that having been the case, though, observations from the Hubble Space Telescope, which has peered deep into the cores of galaxies all across the sky, seems to have confirmed that most, if not all, galaxies have this kind of phenomena. The normal kinds of black holes made when stars explode range from 5 to about 100 times the mass of our sun, more or less. But the central galactic monsters are millions of times more massive, and some have grown to billions of solar masses. Now, a lot of mysteries remain, such as how did these black holes form in the first place, and how they grew so enormous so fast, and what role they played in their host galaxies' formation. One odd question in particular nags at astronomers: what's the galaxy size cutoff where this trend stops? In other words, is there some lower limit to how massive a galaxy can be and still harbor one of these beasts? So, as I mentioned before, orbiting the Milky Way is a menagerie of smaller dwarf galaxies, some so tiny and faint that you need huge telescopes to see them at all. But two are so large and so close they're visible to the unaided eye if you're in the southern hemisphere: the Large and Small Magellanic Clouds. The Large Magellanic Cloud, or LMC, is the bigger and closer of the two, and it's not clear whether it harbors a supermassive black hole. If it exists there, it must be quiescent, meaning that it's not actively feeding on matter. As material falls towards such a black hole, it forms a swirling disk of superheated plasma that glows so brightly it outshines all the stars in the galaxy combined, and we have seen no evidence of this, nor have we seen any Hawking's radiation or anything else that would suggest that there is a supermassive black hole there. But here's the problem. There are quite a number of hypervelocity stars that seem to have come from this region of our galaxy, or just outside of our galaxy, and this includes, by the way, a star known as Barnard's star, the second closest stellar system to our sun, just over 6 light years away. And even though Barnard's star doesn't travel quite as fast as most hypervelocity stars do, it has just under the amount of velocity necessary to leave our galaxy. It's still traveling much, much faster than any other stars in our region of space, and it appears that it came from this same region of space. So here's the problem. If there are hypervelocity stars coming from this region, and it does appear that that's the case, there are a strangely large number of them coming from this galaxy, then where is the supermassive black hole that sent them this way? And a recent paper concerning the origins of at least the hypervelocity stars that we're aware of have determined that the supermassive black hole at the center of our galaxy really seems to be a point of origin for a small minority of hypervelocity stars. We have detected overall a total of 21 hypervelocity stars moving on the outskirts of the Milky Way roughly in our region of space, in our region of the galaxy. And 5 of these have ambiguous origins. We really don't know where they came from. Only 2 come from the center of the Milky Way. And of the 14 remaining, 3 come clearly from the direction of the Large Magellanic Cloud. That means that less than 10% of the hypervelocity stars that we've detected thus far are actually coming from the center of the galaxy, and a larger percentage are coming from the Large Magellanic Cloud. This flies in the face of the entire model that suggests that supermassive black holes are responsible for hypervelocity stars, because the vast majority of them are coming from neither the Large Magellanic Cloud nor the center of the Milky Way. And the only other point of origin that might have a supermassive black hole would be another galaxy. This suggests that the rest of the hypervelocity stars that we have seen in our galaxy actually originated in a different galaxy. This doesn't seem very likely at all. The idea that the majority of hypervelocity stars came from a different galaxy and only a small minority came from our immediate neighborhood. And there's another big problem with this theory. We have carried out an extensive and thorough study of galactic clusters, both in our immediate region of the universe and also further afield. And we have found a lot of evidence for stars existing between galaxies. Actually, about 15% of the starlight that we have detected from any given galactic cluster seems to be coming from stars that are between galaxies rather than forming inside galaxies. This is very strange and flies in the face of what we think we understand about stellar formation. Stellar formation requires highly concentrated gas and matter in order for stars to form, and there is little to no matter in intergalactic space. Therefore, this starlight must be coming from stars that were ejected from their various galaxies and are now traveling between galaxies. But here's the problem with that theory. Younger galactic clusters should have fewer intergalactic stars because they've had less time for their supermassive black holes to eject stars from their various galaxies into intergalactic space. And older galactic clusters should have more. We should see a lot more intergalactic starlight in older galactic clusters than we should see in younger galactic clusters. But that is not the case. The percentage remains pretty constantly at about 15% for young and old galactic clusters. Once again, if these stars are coming from supermassive black holes, if that is what's causing these stars to travel from galaxy to galaxy, then we should see something very different than what we are observing. What we're observing is evidence suggesting that stars travel from galaxy to galaxy regardless of the age of the galactic cluster. And this makes a natural explanation for hypervelocity stars very difficult to support. All right, so now we know a little bit more about hypervelocity stars, but what about the artificial explanation that I've talked about here in this episode? How would it be possible for even an extremely advanced alien civilization to accelerate a huge star to these kinds of speeds, to relativistic speeds that once again are so much faster than even objects like 3I Atlas? How could technology, even extremely advanced technology, possibly make this happen? Well, it is possible, and it's something that's been investigated extensively over the decades until a very compelling engineering design was created. This is a stellar engine designed by astronomer Matthew E. Kaplan of Illinois State University. The idea is to harness stellar energy through what's called a multi-bussard ramjet in order to provide thrust. A bussard ramjet sucks in material and ionizes it in order to produce thrust. And in addition to that, this design also uses jets of directed plasma to stabilize the engine while it pushes against the star. Now, granted, stars are colossal, and this kind of engine would utilize 1 trillion kilograms of solar material per second in order to produce a maximum acceleration of a pathetic 10 to the negative 9th power meters per second. It would take 5 million years to get something like this up to a speed of only 200 kilometers per second. But compared to the overall age of the star and the overall age of the galaxy, getting velocities in the vicinity of 1,000 to 1,700 kilometers per second would take a very short amount of time, as I said, compared to the overall age of the galaxy. And this thruster would also allow the star to travel about 10 parsecs, a little over 30 light years, over a period of 1 million years. Theoretically, this engine would work for 100 million years given the mass loss rate of the sun, meaning that the stellar material would definitely last long enough to drive a star up to speeds of 1,000 to 1,500, perhaps 1,600, 1,700 kilometers per second, and slow down, and there would be more than ample stellar material left over after the journey took place. Now, fortunately for stellar engine fans, there are more efficient versions of this. One is something called a star tug that was proposed by Alexander Savornos of Yale University, and it combines aspects of this Kaplan engine and something called a Skodov thruster, which is a partial Dyson sphere, a giant parabolic mirror that utilizes the sun's own energy in order to provide thrust by reflecting that energy back at it. The idea is to use mass lifted from the star, similar to the way the Kaplan engine does, but instead of pushing a star from behind, it pulls the star from the front via its gravitational link to it, which a Skodov thruster also does. As a result, it only needs to produce a single beam of thrust as opposed to 2 beams of thrust from the Kaplan engine, and the result is that the Savornos star tug ends up being a much more efficient engine capable of significantly higher accelerations and maximum velocities. A Zvornos star tug, theoretically, if you had the right efficiency, could accelerate a sun to 27% of the speed of light before it ran out of mass. So you could easily accelerate up to a speed of about 1,700 kilometers per second without consuming too much mass from the star itself. Why in the hell would you want to do this, by the way? Well, the best way to travel from star to star, at least theoretically, is to take all of your planets with you. Instead of embarking on extremely long interstellar journeys that could take years, if not centuries, in small spacecraft, no matter how big the spaceship is, it's still a bit of a prison. You take your solar system with you, and then there's no rush. You can relocate your entire civilization to a different part of the galaxy. Granted, it does take time, but it certainly takes a lot less time than any other method. And another possibility, if you were traveling somewhere in close proximity to a supermassive black hole, you could engineer a close approach to increase your acceleration, to increase your velocity. But that would be a bit dangerous. Sudden acceleration caused by massive gravitational tidal forces would probably rip your solar system apart as well. And incidentally, this is another interesting phenomena that tends to fly in the face of the natural explanation for hypervelocity stars. We have found at least one, and this happened very recently, hypervelocity star that has at least one planet traveling with it. This should be impossible. The massive gravitational tidal forces of a close approach with a supermassive black hole should rip a solar system apart. There should not be a planet traveling in close proximity to a star because the black hole's gravity is far more powerful than the star's gravity. A star should not be able to hold on to any planets when it makes a close approach with a supermassive black hole. And yet somehow this one has. But all this having been said, is there actually any evidence for the existence of these kinds of stellar engines, or is this all science fiction? Well, interestingly enough, the closest high-velocity star to our own planet, Barnard's star, which I mentioned before. By the way, this is not a hypervelocity star. It's traveling at about 2 to 3 times the speed of 3I Atlas. Still very, very fast, much faster than any star in our region of space. This thing has some strange behavior. There is a wobble in the star, indicating that there is some kind of large object in orbit around it. This is led to the supposed discovery of planets on a number of different occasions. However, all of these discoveries have later been debunked. A number of extremely small planets have been discovered orbiting Barnard's star, but none of these planets can account for this strange wobble, this strange behavior that we are seeing with this star. In addition, we know that Barnard's star is a very old red dwarf. A red dwarf of this age should be quiescent. It should not be all that active, and yet we recently saw a massive solar flare transpire on this star. Again, this is something that should not have happened at all with a star this old, especially a red dwarf this old, and yet it did. This is a very strange star. Again, not hypervelocity, but traveling very fast in close proximity to our planet. Could it perhaps be the source of all the UAP sightings that we have made over the last 70 years or so? Given the fact that our civilization has been blasting out radio signals for the past century or so, if there is a civilization orbiting Barnard's star, they are definitely aware of our presence and have been aware of it, again, for almost 100 years. This is not the only example. in addition to that, a stellar engine that uses a binary pair of a pulsar and an ordinary star in order to provide thrust. The pulsar's interaction with the ordinary star causes the star's material to erupt from the surface, providing the desired thrust. This is another theoretical stellar engine that's been proposed, and there is a particular pair known as PSR J1959 plus 2048 that appears to be behaving in a way that could be interpreted as a steerable stellar system, a star that is being steered by its pulsar towards a desired destination. Once again, these are isolated examples of possible stellar engines. We don't have a lot of hard evidence for their existence yet. We know that they can be built, but that is not the only prerequisite for their existence. Then again, we haven't put a whole lot of effort behind trying to find them either. So what I find so frustrating about all of this, and this is typical for anything that I talk about when it comes to aliens or when it comes to UAPs, that sort of thing, is the fact that mainstream science won't even investigate the artificial explanations, that they won't entertain these things even when natural explanations seem to fall flat. Instead, they simply revert to the fallback adage of, well, if we haven't found a natural explanation yet, there must be an explanation somewhere. If there's no supermassive black hole at the point of origin for these hypervelocity stars, well, that just means that we haven't seen it yet. But there's a supermassive black hole there, trust me. Is this the best example of the scientific method in action? Observation, you don't see a thing. Conclusion, supermassive black hole. Until mainstream science accepts the possibility that extremely advanced science might be able to create some of the phenomena that they are observing, and if only one of these phenomena turns out to have an artificial cause, then that is the discovery of the century, if not the discovery of all human history, the definitive proof that there are other civilizations in the universe, and some of these civilizations are far more advanced than we are. Why are we not more interested in discovering something this groundbreaking, something this earth-shattering? Well, I tend to think that it's nothing to do with cover-ups. It's nothing to do with hiding the truth from the public. It is more to do with a dominant paradigm and the notion that we don't want to believe that other civilizations could be that more advanced than ours. And so it's best instead to cling to our natural explanations, even if they don't quite do the trick. Cling to what we know and don't explore what we think is impossible, because if we discover that the impossible is possible after all, that undermines everything that we ourselves believe and everything that we have convinced the general public to believe as well. Thank you very much for watching. Please don't forget to like and subscribe, and also the merch store is open. I'm going to go ahead and show you a few of the shirts here. UFOs are real. Let me give you a better look at that. Then my Apophis shirt. In 2029, kiss your asteroids goodbye. And finally, 3-Eye Atlas. Store will be open for a few weeks this month, so if you're interested, please check the description. That's the way to support this channel as well, or you can support me on Patreon. Thanks again for watching, and until next time, stay angry about space.